Okay. In this video, we will discuss about block world problem. What is a block world? What are the operations in it? And what are the predicates? So, in block world problem, first we'll learn the predicates, and then we'll go to the operations. So, we have five predicates over here. Okay. What are these predicates? First, we have on. In short form, we can write it as O. Okay. So, O of x comma y. So now we will take an example of a block, such as, yeah, let's take the textbook example B, A, C, D. Now here B, A, C, D are blocks. This line over here is the table. Okay, that line is the table. B is over A, C and D are on the table, A is on the table. The top of C and D are clear. And then in a blockward problem, you'll also have something called as the arm. Okay, there will be an arm, a robot arm. So now we have certain predicates to define certain functions of this block world. For example, on of x comma y, that is O of x comma y. For this example, we can say block B is over block A. So this we can give as O of B comma A, which means that this block is on top of this block. So block B is over block A. Then we have T of X. T of X means on table, okay, which means that that block is over the table. So if we take in this example, what are the blocks that are on the table? We have T of A, then we have T of C, and we have T of D. These are the three blocks which are on the table. Then we have clear, that is C of x. Only a single variable can stay in them. So C of x means clear of x. That means the top of that block, okay, top of this block is empty or it's clear. So in this case, we have three examples actually, B, C, D. So we can say the top of B is clear. There's nothing on top of B, and top of C is clear, and top of D is clear. So three blocks are clear on the top. So we define it as C of x. Then we have holding of x, that is h of x. Holding of x means, as you can see, there is an arm over here. It can carry one block at a time. So the arm can carry one block at a time. In case I have to pick up B, then we can show it, we can signify it as like this. Uh, That means the arm is holding B. So this we can define with h of x. That means h means holding, and inside we have the block that the arm is holding. In this case B. So we can write h of B. Okay, h of B. Now consider the previous state where block was over here, and the arm wasn't holding anything. The arm was empty. This state is called arm empty, AE. It's just a predicate. There is no variable for it. So arm empty, which means the robot arm is empty. So these are the five predicates. O means on, T means on table, C means clear, H means holding, and A means arm empty. Arm empty. So O, what did we say of O? O means O of x comma y. It has two variables x and y, which means block x is on top of block y. What was T of x? T of x means on table. That means the block, this variable, is on the table. C of x means the top of this block, okay, this variable is clear. There's nothing over it. There's no other block on top of it. H of x means the arm is holding that block. A means the arm is empty. So these are the predicates for block word problem. Now we will know what are the operations or operators in the block word problem. So we have four operators here: unstack, stack, and pickup. Now let's know about stack. Let's consider the same example, which is over here. Okay. So consider we want to unstack block B from block A. Now remember, unstack operation can be done only when a block is over another block. Okay, if a block is on the table directly, then there is another function for it. So unstack means you can remove or pick up a block which is on top of another block. Now in this case, unstack of B comma A means block B is on top of block A and I want to remove it. Okay, I want to pick it up which was on A. So since this is an operator, it will have certain preconditions because you're unstacking B comma A. There are certain conditions that it must follow. So this is an operator. So what could be its preconditions? Okay, precondition. So the precondition for this is you are unstacking B comma A. That means A is on the table, and the arm is here. So what could be the possible precondition that you can observe? First thing, on top of B there shouldn't be anything. So C of B, that means on top of B it should be clear. So clear of B, and then since you need an arm to pick it up, you need the arm to be empty. AE. So these are the preconditions for unstack. First, the precondition is the top of B must be clear and the arm must be empty. Only then you can, if both of these are true, okay, only if both of these are true, you can perform unstack. Otherwise, you cannot. Then you have stack of x comma y. In this case, let us consider B was already picked up, okay, during unstack, and you want to put it over block D. Example. Now I want to keep block B over block D. This is the operator. So what could be the possible preconditions? Okay, what could be the possible preconditions? Now since you are placing block B on D, obviously the top of D must be empty. Correct. Top of D must be clear. Then since you are placing B on D, in order to place it, the arm must be holding B. So holding of B, the arm must be holding D in order to put it down on D. So holding of B. Then what could be the other conditions? That's all I guess. We can check it over here. For the first one, we had R must be empty, the top of X must be clear, and for stack we have C. The R must be holding the block X, and the top of Y on which you are keeping must be clear. So these are the two conditions for that. Correct. Now we will go to put a pickup. Okay. Now we understood both of these must be true in order to for stack operation to work. Okay, otherwise you cannot perform stack operation. Now the next operation we have is pickup of B comma. Pickup is a single variable predicate. So consider you want to pick up A. Now we have placed B on D. Okay, so if I go over here, okay, on in this right side, we picked up B and we placed it on D. Now A has nothing on top, so I want to pick up A. We use the operator pickup of A. Okay, this is the operator. Now even this has some preconditions. What could be the preconditions for pickup of A? First thing, pickup of A, this the operation pickup can only be used if that block is on the table. In case if this block, the block is over another block, then obviously we'll use the unstack operation and not the pickup operation. So pickup operation is used if that block is the last block or the block that is directly on the table. So in case if I have to pick up A, what could be the possible preconditions? First thing, just like unstack, the arm must be empty. Then since you're picking up A, the top of A must be clear. Only then the arm can pick it up. Then obviously it should be on the table. Only then you are picking up A. If it was on some other block, then you should use unstack rather than pickup. So since This is not the necessary condition, but this is what will differentiate pickup from unstack. Okay, so these are the two main conditions. The third one is more like to differentiate pickup and unstack. So final operation is uh, put down PD. So now you have picked up A, so only then you can place it down. So put down operation is used when the arm is holding a block and you want to place it on the table. Again, you if you want to place this block on some other block, then you use the stack operation and not the put down operation. Okay, so the precondition for put down will be, actually there will be only one condition, that is holding of A. There is no other condition. There is no predicate for table clear or something. Means the top of the table should be clear. There is no such predicate here because we are assuming that the table is long and infinite. So obviously there is no condition for C of a table or something. No, that condition is not there. So the only possible condition is to put down a block, the arm must be holding it. So holding of A. So only if that condition is true, you can put down A on top of the table. So these are the operators and predicates of the block weld problem. Next, we will solve a problem that is this using goal stack. Okay. Okay. Let us consider this problem. Uh, we have this start state over here, and we have to reach this goal state. And this is a block world problem, and we will be using goal stack to obtain our solution. So what is a goal stack? Goal stack is like the name suggests, if you know what is a stack. So it's a stack where you store all the goal conditions. Okay, the conditions for the main goal, okay, the final goal, and all the sub goals for all the processes in between. And slowly you pop as each one of them become true. Okay, each one of them become true, you just pop them. So that's a goal stack. So how will we use that in a block world problem? So as you can see the question there, it's the same one as the previous example that we took. So let me draw it over here. This will be a lengthy problem to explain, but you can reduce it later on. So our start state is this. So we can write the start state as state 0. Okay, we can consider it as state 0. The arm is empty. We have B, A, C, and D, and this is the table. So what? How can we write this in terms of the formula based on the predicates that we just learned? We can see write everything that you can see in the start state. Okay, so we can say start state. Okay, we can say that the start state, first thing, what can you observe? B is over A, right? So we can write on B comma A, which means block B is on block A, correct? One more thing, in these unstack and stack operation, there is one more precondition. Since we are picking up B from which is on top of A, we can write O of B comma A. Even this should be true, because only if block B is on top of A, you can pick it up. It's not mentioned in this table over here. Over here, we didn't mention it, but that's a necessary condition. Okay, because if you have to unstack some block B which is on block A, first it should be on block A. Okay, you must find that the block B is over block A. If it is not, then how are you unstacking it? So that's one condition needs to be true. If there's any changes on in these preconditions, you will come to know in this problem. Okay. So now you can observe that block B is over block K. Is there anything where you can apply on, that is on of x comma y? No. Next, let's go to the next predicate, table. On table. You can see there are three blocks that are on the table. So we'll write that. Sorry, we use T of. Okay. So T of A. and T of C and T of D. These are on the table. Then we'll use the next condition. What do we have after on table? We have clear off. So which are the blocks that are cleared on the top? The top of the block is clear. You have B, C, and D. So we can write clear of B and clear of C and clear of D. Okay. Then what is left? Everything is done. We know what are the next predicates we have. We are done with on table, clear. Then we have holding. Holding, the arm is empty. It's not holding anything. So obviously you can write arm empty. Okay. Yeah, whenever there's a holding, there's no arm empty. And whenever there's arm empty, there's nothing holding. Okay. So it's vice versa. So the arm is empty, so we write A. If it's holding, we write H of something. So this is the start state in terms of the formula. What is our goal state? Okay, our goal state we can see here. Our goal state that we want to achieve is block A must be over block C, block B must be over block D, and R must be empty. And this is the table. So this is our goal state. So what can you observe in the goal state? We'll go on writing. When it comes to predicate on, A is on C, so we write O of A comma C, and block B is on D, so on of B comma D. And is there any other on predicate we can do? No. So we can do on table. So which are the blocks on the table directly? C, D, and then that's done. Which are the blocks that are clear on the top? A and B. So we write C of A and C of B. Then is the holding operation, holding predicate possible? No, the arm is empty. So we write and of A. Then we have something called as plan Q. That means to perform this operation, to reach from start state to goal state, we might have to do certain operations. The unstack, stack, put down, pick up, those are the operators. So how will you plan that? In what order should they go is stored in plan Q, which is currently empty. Okay, which is currently empty. So now I'll just zoom out a bit. Okay. Uh, we will take some common things because this is a very long equation. You can't repeatedly write the same. You cannot write it again and again. So we'll reduce it by taking some common terms. What can you find common in both of the equations? First, you can find TC. You can find T of T. You can find C of B, and you can find E. So we can, for convenience purposes, let us take this as CSG. Okay, what is CSG? CSG means conjoined sub goals. Okay, conjoined sub goals. It's just for our convenience. Okay, it contains. We'll just write it here. It's better to write that what the CSG mean wherever we use it. So it is T of C and T of D and C of B and A of E. So whenever we write CSG, it means these four must be satisfied. The reason being, these four are the common predicates in both the goal and start state, which means that since the start state till the end goal state, these four predicates should remain the same. Because since they are there in both states, there shouldn't be any changes in them. So in every step of our solving or every state, the intermediate states, this condition should always remain true. That means this CSG should stay true at all times. Okay, that's what we'll make sure of. So now we'll start solving. Okay, first we know, let me just write the diagram over here. Basically, this was our diagram. Okay, first operation what can we perform? Okay, the first operation that we can perform is unstack, correct? We can perform unstack of b comma a because in goal state we are placing b on d. To place b on d, first we have to pick up b. Now, logically speaking, that's very quick. correct? If you just logically if you see the diagram goal state, you can directly know what are the steps required. First pick up B, then place it on D, then pick up A, place it on C. Just done with just 4 steps. Something you can get it done. But they are specifically mentioned that we have to solve it using goal stack. So there is one problem with goal stack. It creates very lengthy, what is it, multiple intermediate steps, and the process becomes very lengthy. You will know more about that in Sussman anomaly problem. So here the steps are very less. So we'll start in goal stack. Okay, first we will write the final goal. Okay, what is our final goal? O of a comma c and O of b comma d. And is there any other after we took the common out? Yeah, we have this one c of a. So we'll write that over here and c of a, and then the CSG. Okay, the CSG. These should be true. Now, what are the preconditions for it? Nothing. You just have to write these things in any order you like. Okay, in the stack. So we'll write O of B comma D, O of A comma C, and then I write C of A comma C of A. Okay, which means that for this final goal state, okay, this is the goal state. For it to be satisfied, i- all of these must also satisfy. That is the condition. So we push it into the stack in any order you like. Whatever you do while solving, it will solve correctly. Okay. So you just push it into the stack, which means that whenever each of these conditions become true, you pop them from the stack. So as you go on doing that, you will pop the final goal state, and that means that your problem is solved. So now this is our current goal stack. It has the goal state and its preconditions. Now let's start with the first element, the top element of the stack, C of A. We have to make this true. So let us check our state 0. This is our state 0, right? Which I have drawn here. Is C of A true? That means on top of A it should be clear. Is it? No. It is false. Correct? It is false. C of A is false. Let us go here in order. Okay, C of A is false. That means how can you make C of A true? You have to pick up B. Okay, you have to remove B in order for C of A to be true, correct? To make top of A to be clear, you have to remove B. And if P is a block over another block, what operation do you use? Pick up or unstack? We have to use unstack. So we will use the operation unstack of, we are picking up B from A, so unstack of B comma A. This is what you'll do now to the goal stack. Now our goal stack will change. Okay, if this is false, what you will do is you will pop C of A you will pop, and you will push this. Okay, you will push unstack operation and its preconditions. Okay, so what you will do, you will pop. Okay, and remove this stuff from here. Okay, I will maintain this place entirely for the stack rather than drawing it repeatedly. We will pop this thing, and then we will push the unstack operation, unstack of b comma a. This is the operation, okay, operator, and its preconditions. What were the preconditions that we studied earlier? First thing, b must be on top of a, then arm must be empty, then the top of b must be clear. These are the preconditions for unstack. So these will be our preconditions. You can push them in any order. They will ultimately solve correctly. Okay, but just go in the simplest one, which you know that immediately it will get popped out. Okay, so write it in that order. So now we have arm empty, clear of B, and B on top of A. These three predicates must become true in order for unstack operation to pop out or to become true. So now we start checking the next one, the next condition on top of the goal stack, that is AE. Now this is our current goal stack. Okay, this is our current goal stack. So what do we have on top? AE. arm empty. So is arm empty true? Okay, this is our second step. Till now there is no change in the state. Okay, the state is still at state 0. So is the arm empty? Yes, the arm is empty right now. There is nothing holding in the arm is not holding anything. So since the arm is empty, we can pop it out. Okay, it is true. So we will pop a. Okay, it is true. I will use the same gold stack over here which is shown. Okay, I'll just remove this for convenience. Okay, so we have popped this thing. Now next thing that we have to check is CB, correct? So we will check whether CB is true. Is CB true? Clear of B. Clear of B. It is true. On top of B there is no other block, so it's C of B is true. So we'll pop that. Pop C of B. So we'll pop C of B over here. Done. Another precondition satisfied. Now we'll check the. I'll write it over here. Okay. Fourth one on O of B comma A. That means B should be on top of A. Is that true? Yes, that's also true. So we'll pop it. This implies pop. So we'll pop this. Now, if all the preconditions are popped out, then you can reach the unstack operation. Now, unstack is our operation. That is why you write preconditions, because only if they are true or false or any of those, once they pop out, only then you will end up reaching the operation. Okay, so that's why you write the preconditions in the stack. Okay, after the operator. Okay, now we popped out this unstack of b comma a. We will perform it. Okay, while you perform it, you just pop it. If you are for predicates, if they become true or false based on the requirement, you pop it. For operators, when you're going to perform the operator, you have to pop it. So right now, unstack of b comma a is popped. So that's no longer there in the goal stack because we are performing the operation now. So this is popped and we'll perform it. Okay, we perform the operation. Now you can write the state 0 to state. I'll write here state 0 to state 1. What was the state 0? B was on A, C, D. This. What was the operation we performed? We performed unstack of B comma A. And what did we get now? Arm is holding B, A, C, D on the table. This is our state 1. As you can see, the arm. Okay, this is the arm over here. Just a arrow. Okay, the arm is holding B. ACD is on the table. This is our state 1 after unstack operation. So now, after that's done, you have to insert this operation into the plan queue. Okay, we had a plan queue which was null or empty. Now we will write the plan. What is the first operation we have to perform to reach the goal state? Unstack of b comma a. Done. Okay, I have written the goal stack separately so that it's clear. Now we'll consider state 1 that we had obtained over here. Okay, we had obtained this state. Okay, I'll write it over here for convenience. Okay, I'll write it here. And now we'll consider what is the predicate on in the top of the stack, that is O of A comma C. Is O of A comma C true? Consider state 1. Is A on top of C? No, it is false. So we will write false and now we will pop it. We will pop it and we will write the operation that is required to make A on top of C. So to make A on top of C, you use stack of A on C, obviously, because you are stacking A on top of C. That's the operation required to make A on C. So we will push this operation and its prerequisites or preconditions. So we'll write stack of A comma C. This will be our operation. What are the preconditions? First thing, the top of C must be clear, and then A must be held by the arm, and that's all. These will be the preconditions. You can write this, write it as a sub goal like this, okay, which I didn't do in the previous one, the previous operation for stack. It's required. So these will be our preconditions, okay. This is similar to the goal state over here, okay. This will be the sub goal. That's all. So only if this signifies that both of these preconditions must be true. Okay, with an and we have signified that both of the conditions must be true for this operation to work or to be executed. So now we'll go to the first operation, C of C. Okay, is that true? Yes, correct. The top of C is clear, so we will pop that. Okay, then we have H of A. H of A is the arm holding A. No, false. It's not holding A. Okay, it's not holding A. So what you'll do is we will pop that and we will do the operation such that you can hold A. So to hold A, what is the operation? Pick up A, correct? You write here pick up A. Okay. So this is the seventh step. Here we will pick up A because you want to hold A, right? So the operation that can hold A is pick up A. You have to pick up A so that the arm can hold it. So this operation is pushed and its prerequisites as well. So we will use push or pick up of A and its preconditions. To pick up A, what should be the conditions? First thing, the top of A must be clear, and if a top of A is clear, then you need the arm to be empty. Uh, is there any other preconditions required for pickup of A? Yeah, it should be on the table. Yeah, that's the other condition that we had for pickup, right? Not the necessary condition, but it's the one that differentiates, right? Pickup of A, and then the arm must be empty. You want to pick up, right? So you need the arm to be empty. So we will write that over here in any order. T of A of E. This will be our goal stack right now. Okay. So the arm should be empty in order to hold, and then the table A should be on the table, and the top of A must be clear. So we will check that. The first operation in the stack we have right now is AE is the arm empty, no false. It is false. So we will pop it again. And now we will write the operation that will make the arm empty. Okay. So wait. We will pop arm empty and we'll push an operation that can make the arm empty. Okay. We will remove this precondition stuff as well. Okay. It's not required. Right now our preconditions are different. Okay, we have many different preconditions. So we can say that for this operation, this entire stuff is the precondition. For this operation, this entire stuff is the precondition. And what operation we write now? This will be the precondition. Okay. So AE we have popped, arm empty is popped. How can we make the arm empty right now? By placing B. And how can we place B? We must place B such that it is matching the goal state. Our goal state we want B on top of D. So to place one block on top of the other block, the operation required is stack. So we will stack block B on top of block D. This thing is pushed onto the stack along with its prerequisites. So we will place that over here. Stack of B comma D. This is our operation. These are all our prerequisites or preconditions. So what are the preconditions for stack of BD? First thing, the top of D must be clear. Then B must be held by the arm, and yeah, we can write it as a sub goal. Okay, and it should be and let's see of D. Oh, this is our stack right now, a pretty huge stack. But yeah, So these are the conditions for stack of BD. The top of D must be clear and the B must be held by the arm. Now we will pop the first, sorry, we will check the top of the stack, C of D, correct? So we have C of D, clear of D. Is the top of D clear? Yes, it is. We are still considering state 0. There has not been any change in the state. So we will clear D. Okay, the top of D is clear, true. So we will pop that. Okay, C of D is popped. Next thing we have is hold of D. Is B held by the arm? Yes. So hold of D is equal to true. So now is the sub goal satisfied, that is C of D and H of B? H of B, okay. H of B. Is it satisfied? Yes. So right now you can perform the operation, that is stack of BD. Okay. You can perform stack, sorry, you can perform stack of BD. Okay. I'll take a thicker pen. Yeah, this is better. So we will do stack of BD. Okay, we will pop these things out. Okay, once you are executing, you are popping those items. Okay, you have popped those items from the stack. We are performing stack of BD on the state one. Okay, let us place it over here, and we'll write the next state. So next we are performing stack of BD. The state changes to state 2 and A, C, D. On top of D we have placed B and the arm is empty. Okay, this will be our new state. Okay, this will be our new state. Now we'll check the goal stack again. 10th step. Goal stack as T of A. We will check that is T of A is A on top of the table. Now we'll consider state 2. Is it true? Yes, A is on the table. True. So you'll pop it out. Okay, you will pop that out. I'll just strike it off. Then you have C of A. Okay, C of A. Is it true? Is the top of A clear? Yes, it is true. We will strike that off as well. And then is the sub goal satisfied? C of A and T of A both are true. And the arm is empty. Is it empty? Yes. So this thing is also popped. Now we are left with this one. That is also popped because it's an operation. So we will perform it right now. It is popped. So we will perform pickup of A. Okay, we will perform pickup of A. We'll write the state over here. Okay, we'll write it over here. This is our stack right now. State right now. We will perform pickup of A. We have picked up A. We are transitioning to state 3. We have picked up A, so the arm has A. We have C, D, B on top of D table. There you go. That's our state 3. Oh, another thing. While we transitioned here from state 1 to state 2, we had to update the plan queue. Okay. When we transition from state 1 to state 2, we update the plan queue, which had uh, unstack of b comma a, I guess, correct? It is our plan queue, yeah, unstack of b comma a. Now we will commit it with the this one. Okay, stack of bd, stack of b comma d. This was our plan queue earlier. I forgot to mention. Now from state 2 to state 3 we have performed another operation. So the plan queue again gets inserted with a new value. So unstack of b comma a, stack of b comma d. Then we have pickup of a. This is our new plan queue. And now we'll go to the 11th step. Okay, the 11th step will be this one. Yeah, is C of C and H of A. That means, hold, wait, oh, why did that come there? Yeah. This was the sub goal for stack of AC. Yeah, we are correct. So we are checking C of C, the sub goal. Is C of C and H of A true? Is it true? Is the top of C clear in state 3? Now we are considering state 3, which is over here. Okay, let's copy paste that over here. So we have the state 3 over here. So is the top of C clear? Yes. And is the arm holding A? Yes. So this becomes true. And so we pop that from the stack, which we have right now, and we'll pop this operation as well, because now we are able to perform that operation. That is stack of A comma C. Stack of A comma C. We will perform this operation and pop it from the queue, okay, which we have, and we'll perform it now. Perform operation stack of A comma C. We have reached the new state, state 4, which is our goal state. We have placed it on top of C, D, and here you go. This is our we have reached the goal state. The arm is empty. This is our goal state. Now we push this operation onto the plan queue. Okay, the plan queue is now updated again. So I'll just copy it here. Let's get it done quickly. Okay, we'll copy paste this stuff over here. Okay, so here we have. We will just include comma stack of A comma C. This will be a new plan Q. And this is our final plan Q. Okay. The reason being, we will again perform pop. We will check whether this is true. O of P comma D. Okay, is O B comma D true? Is B on top of D? Yes, it is true. So we will pop this thing out again. Now we are left with the final goal. We will check that, which is also true. That is O of A comma C is true. A on top of C true. O of B comma D true. C of A, that is top of A is clear true. Then is the CHG still true? Yes, the CHG is still true. That is C of D, C of B, and all of those are true. So, yeah, we have reached the final state. We will pop that as well from the goal state, from the goal stack. Okay, we pop this. Now the stack is clear, and that means we have finished solving the problem. This is our plan Q for the block world problem. That's all. We just write the transition as well. We write all the transitions, that is state 0 to state 1 to state 2, state 3 to state 4, and all of these intermediate steps, which are just small. You just have to write true, pop, what is operation inserted, false, push, perfect, all of those things you have to just write it down. That's all. And the stack, you might have to write it repeatedly, but writing it maybe 3 times is more than enough. Yeah, that's all.